6 o'clock, so I'm going to get started with class today. Welcome back to our Java class. And just a quick summary of what we did last week. We learned about the new data type strings, which store basically text. And it's kind of like the primitive data type character, except that instead of a single character, it's a bunch of characters. And we also learned the idea of what indices are. So when you have a string, each character is numbered. And the important thing to remember is that the numbering, the indexing, starts at 0, which is maybe not what we're used to when we're normally counting, right? When we're counting objects in real life, usually we start with 1, 2, 3. But in computer science, we start counting at 0. And so that means the first character in a string has index 0. The second character, index 1, third character, index 2, so on, so on, so on. And then using those ideas, we learned a couple different methods, things that interact with strings, such as the char_at method, index of, the length method. And we're going to go over that with a review question as well as going over the homework. So first, let me share my screen. Let me get PowerPoint up. So this is kind of one question, just remembering what one of our methods was. So there's a method index of, and there's a couple ways of using it. But one way is to pass in two things to it. So here I'm passing in the string C, and I'm also giving it the number 2. So does anyone remember what is the purpose of these two inputs to our method? Like when I say C right here, what does that mean?
How many C's there are inside the sentence?
Close. I think you had the idea. Index of does not return the count of something. That would be a different thing. Evan, I see you have your hand raised.
It gives you the number of the character inside of the it gives you the first character, the position of the first character it sees after the specified position. The specified position.
Yeah, so that's a great answer, Evan, and I see Kaden put in chat. And yeah, so what I was going for is actually a little bit more simple, but you guys answered it great. The C is just what we're looking for. So here I'm looking for C's in my string, which I think we got. And 2, like Evan and Kaden said, is kind of telling us where we're looking from, the starting position of where we're searching in our string. And so we use indices. So this means starting at position 2. Yeah, I think, Eileen, I think you might have your mic unmuted. Yeah, okay. No worries about that. But yeah, so what this is saying is, give me the index of C, and I want to start searching only from index 2 forwards. And what we said last position it will find C, right? So it doesn't give you all of them if there's multiple C's. And so for example, if we look at the string like cupcake, I put the indices to make it a little bit easier. So C is index 0, A is index 4, E is index 6. Here, what it's going to do is it's going to look for C's, but it's only going to start looking from index 2 forwards. So while there is a C at the very beginning of our string, it won't see that. It won't find it. Instead, it will give us the position of this C, and it will return 3 because that's the index of the character. And so, for example, I can show it in Eclipse if I open up here. So let me set this up, public static. So if I make a string S, and this is cupcake, if I print out what S dot index of, and then the C and the position 2, and I run it. Oops, I'll just proceed. Don't think it matters. Yep, we get 3. And so again, the reason for that is that it looks for C's, which exist here and here. But since we have this 2 here, it'll ignore the first one because that's too early. If I remove the 2, it will still work. So index of doesn't need to have that number. It can just take in what we're looking for. And in this case, it'll give us 0 because now, since we didn't tell it where to start, it starts from the beginning. And the very first character is the C, and the index of that character is 0. Yep. And since I think there was a little bit of confusion of when we say 2, does it mean starting from 2 or after 2? So what we can do to test that is if we put a 3, we know the index of the C is 3. And so what this returns will tell us, does it start from here or start after this position? And if we run it, we'll see that we get 3. So that means this number is where it starts the search from, and it includes the character at this index. Let me check. All right, so I think got some people joining from the waiting room. Now I want to go over the homework from last week, and I got a little fewer submissions than normal, which is fine. But I want to make sure that we do our best to try the homework. It's completely fine if you forget about it or if you have trouble, but in those cases, I would prefer if you reach out to me so I can help out. But anyways, this homework for last week was just practicing using kind of the index of method and finding the length of strings and just working with strings in general. And so in the assignment, I gave you this string to work with, hello all audiences. It was just a random string, has no real meaning to it. And there were a couple steps of what I wanted you guys to do. And so what I'm hoping now is that I can call on people or people will volunteer to tell me how to fill in these blanks. So I have most of the code written, but the important parts I've left out and put blanks. And so the first part was kind of similar to our review question, but here I want to find the last index value of the letter A, and I only want to start looking from index 8. So I don't want to start from the end of the string or the start of the string. I want to start from index 8. So can someone tell me what goes in this blank? What is the name of the method that we use to find the last index? Maybe let's have Kaden. Do you remember the method that we used to find last index? So very close. It's like index of, but index of gives us the first occurrence that it finds. Yeah, last index of. And so we want last index of, that's the method name. And the question is now what goes inside here. And Lucas, I see you have your hand raised. Do you have a question or do you want to answer this?
Is the method name case sensitive?
Great question. And the answer to that is yes, it is case sensitive. I want to say pretty much everything in Java is case sensitive. So if I type something that's lowercase, I do it for a reason. If I type something that's in uppercase, I do it for a reason. One thing I like to point out is this kind of way of writing out the method name. This is something called, I think, camel case. And so what that means is that if we have like a variable name or a method name that consists of multiple words, well, we can't put spaces in our code because if we put spaces, that means something special in Java. We don't want that. So we need to kind of combine all the words together. And the way that Java does it by default is that the first word starts with a lowercase letter. So last starts with a lowercase letter. But then every other word starts with a capital letter. And this just helps us identify where the words are. So this is literally just last index of. Okay. And so the capitalization does matter. Okay. So now we want to pass in something. And I think it was kind of already half answered. And it's very similar to the review question. So I'm just going to fill it in. We need to pass in two things. First, what we're looking for. And so in the instructions, it says we're looking for A's. So we put in A. And where are we searching from? We're starting from index 8. And so we just put in 8. Right. So this will take our string, which is right here. We'll search for the last index of wherever an A is, but it will only start looking at index 8. And so what that means is, here's our string. This is index 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is the character at index 8. And since it's the last index of, it starts there and goes towards the beginning of the string. And so we'd expect this to find the index of this character, which should be 0, 1, 2, 3, 4, 5, 6. Should be 6 here. But the second part of the assignment was finding the length of our string. And so it's a little bit of a easy question. Don't feel like there's any tricks here, but Owen, what is the method to find the length of a string? Owen, do you remember?
Oh wait, you're talking to me?
Oh, yes. Sorry.
I'm not entirely sure.
All right. Well, luckily, Java makes it very easy to remember. To find the length, the method is literally just called length. And so it will just be x.length. The important part to remember here, though, is that this is a method. And so we need the parentheses. Whenever we use a method, we have parentheses with the inputs inside of it. Even though we don't have any inputs to this method, it doesn't require any, we still need the parentheses. And so in chat, I see a couple good answers. Yeah, it's length, but remember the parentheses. And so this finds the length of our string. And then I just had you guys do some weird math, take the length, subtract it by the index that you found. And then you get a number, that's the answer. And I want you, the last part of the homework was to take that number and find the character with that index. And so maybe, Lucas, do you remember the method that we use to find the character given an index?
Was it like index?
Close. So index of kind of does the reverse. Index of takes a string or a character and returns the index. What we want is kind of the opposite. We have an index, we have a number,
Character at?
and we want, yes, character at or char at, although I know that's what you were going for. And again, just point out that this is like character at, so it's 2 words, and notice char starts with lowercase c, at starts with a capital A. That's the camel case. But then what we give this method is the index that we're interested in. And so that's our difference. And then we print it out. And so if we run this code, hopefully there are no more errors. It doesn't have too much of an output. It's just the character I. But if you did this on your homework and got I, that's the right answer. And so we can maybe print out a couple more things just to show what's going on. So we can just print out the values of all our variables. And sentence length and the difference. So if we run this, we'll see that the index it found was 6, and that's because it found this A. The length of the string is 19, and so 19 minus 6 is unlucky number 13, and the character at index 13 is I, which looks about right? That looks like it would be roughly index 13. All right, so that was the homework. It was just to practice using like the last index of, length, and char at were the 3 main methods that we learned last week. And so it was just a kind of assignment just to practice using all 3. Does anyone have any questions about this assignment, how we walked through it in class today? Let me zoom out so you can see the whole code. The only thing I want to make a comment of, seeing as there's no questions, is I don't think I said this explicitly last week, but when we're looking at our string, spaces count when we're doing our indexing, when we're doing our numbering. So normally we're used to thinking that spaces are kind of don't exist. It's just an empty gap. But in Java, a space is just like any other character. And so when we're counting, we have to make sure we count the space as well, right? So when we want to say the index of this first A, we go, this is index 0, the H, index 1, index 2, index 3, index 4, index 5 is the space, and index 6 is the A. Right? And so if you skip the space, you'll mess up your counting, and that's not good.
I have a question.
Yeah, sure.
When would you start counting as when age is 0, not 1?
Yes, you do count with H as 0. So H was 0, E is 1,
Oh, okay.
2, 3, 4, 5, 6.
Okay, then I like cut out then.
Yes, sorry for the confusion. But yes, thank you for clarifying. Does anyone else have any questions? I'll probably upload this file to Classroom at the end of class as well. But I see Eileen, you raised your hand.
For this is Ethan. This is Ethan.
Oh,
So
Ethan. Okay.
for the okay. For the second A after the 8th index character thing,
Yes.
it's on index 10, but your thing says it's at 6.
Good question. So the reason why I gave 6 is because in this case, we're using last index of. In the review question, we were using just index of without last. And so the difference between these two methods at a surface level is just index of returns the first place it finds it, and last index of finds the last place it finds the letter. But if you think about how you might kind of program this if you had to write these methods yourself, when you're trying to find the first time you see a letter or a string, you would start from the leftmost side and work yourself to the right, right? And so when we give a number to index of, it's telling us where to start. And from that starting position, we go towards the right. On the other hand, last index of finds the last time it finds something, which is normally towards the end of the string, normally towards the right. And so here, when we have a starting position, we're starting from there, but now we're going left, because like you can think of the starting position as essentially the end of the string, or where we're considering the end of the string. So here index 8 is 6, 7, 8. I think it's this L. And so what this is doing is actually basically saying, or one way you can think of this is, well, let's just pretend our string is cut off after 8, right? So we will ignore everything afterwards. In this case, where is the last time we see an A? And in that case, it's this A, it's index 6. You can see it's kind of the mirror again of we want to start looking at index 4. We will basically ignore the first part up to 4. Right? So index of will ignore the beginning part. Last index of will ignore the second half of the string. I hope that was helpful. Yeah.
Thank you.
Yeah, no problem, Ethan. Does anyone else have questions? Anything they'd like me to clarify? So for today's class, we're actually gonna continue talking about strings for the most part. That's just because strings have a lot to them. They're very useful, they're very interesting. So we spend a lot of time talking about it. But again, some of the concepts that we're gonna be learning today can be applied to other data types, other things in Java. So really, we're gonna be focusing on strings, but we're gonna be learning stuff that's useful for more than just strings. All right, so let me go to a new class file. So again, if you haven't already, I'd like for everyone to start up their Eclipse, start up the IDE, and we're gonna look at some code together. And so before I even go to those slides, I wanna make sure we see one string operator. And so we talked about operators in one of the first classes where we did like the plus, minus, divide, times. Those were our arithmetic operators. And then we had our comparison operators like greater than, equals, not equals. We also had assignment operators. Some of these actually work on strings as well. And the most common one that you'll probably be using is the plus operator, or maybe the plus equals assignment operator. And so we can play around with that. For example, we can say string A equals cat. Let's make 2 strings, string B equals dog. It's 2 strings. And we can do something like string C equals A plus B. And we just print it out. I'll copy this into chat.
Will it print it with like a space or not?
Good question. So let's run it. And we can see that it does not put a space. So what is happening here is, well, so the output, if you didn't see, is cat dog. No space, it's just, yeah. And so what's going on here is that the plus, the addition operator, when you're applying it to strings, will just take the two strings and smush them together. And it doesn't do anything fancy, it doesn't do anything extra. It literally just takes the two strings and glues them together. Another word that we have for this is called concatenation. So the plus sign concatenates two strings. Sometimes you'll just see concatenation when you're looking at stuff online. So I want to make sure we know that word as well. But really, it's just adding strings as you might expect it to.
If you put a space after cat, will there be a like a space between cat and dog when it combines them or when it prints it?
Yes, it will. So if we put a space here, good question, and we run it, now it will have a space. I will say cat space dog. And that's because, well, as we said, the plus operator just takes our two strings and combines them together. Well, now our first string has a space. And so it will keep that space.
Is there another way? Is there another way to do that instead of just using?
Yeah.
Could you use like
Well, there might be an escape character. I'm gonna check if \s works. Yeah, so \s is the space character, so you can do that. Another thing that you'll see somewhat common, it's a little bit annoying, but you can just concatenate with another string. So here we're modifying our first string, which might not be ideal because maybe we want the first string just to be cat without a space at the end, right? And we want our second string just to be dog without a space at all. What we can do is when we're concatenating them together, we can add another string, right? We don't just have to add two strings, we can add three strings together. And we can add the first string plus a space plus the other string. So I see in chat, I have a question, can you use a comma? I just want to make sure I understand this question. What do you mean by use a comma? Like have a comma in the string or use a comma to join strings together? That's your question. Can you use a comma to join things together? I don't think that's common. I don't think I've seen that before. So I would say at this point, no. But you can do things like this where you're adding multiple strings together at the same time. So here we're adding the string cat, the string just a space, and the string dog. We cannot do something like C equals A comma B. This is not valid Java. You can have a comma in the string though. That's fine because it's just a normal character. So you can have a comma and it'll just print it out. And so adding strings together is very useful. And you might think, okay, well, we can add strings together. We learned that there was a comparison operator. So maybe if I want to check if two strings are equal to each other, I'll use the comparison operator that we learned from before. And so just really quickly, does anyone remember what that comparison operator was? What do we do to check if two numbers were equal to each other? What was that operator that we used for equality?
Was it a no. like greater or less than sign, I think.
So those are comparison operators. Those can be used to compare numbers to each other, for example. So you can do the greater than sign, less than sign, greater than or equal to, less than or equal to. But I'm asking for the specific operator that we use to check for equality. And a hint maybe is that it's not an equal sign. It's something, it's a little bit more than just an equal sign. Kaden put in chat, it's 2 equal signs. So it's the double equal sign. And so we might say, okay, let's try to use that for strings. And we can say, let's say A equals B. Let's see what this prints out, right? Well, this will print out false, which is okay, no big surprise here, right? Because cat and dog are 2 different strings. And let's try comparing A with cat. And we run this and we say it's true. Okay, so far, so good. It looks like it's working, right? If we say cat equals dog, that's not true. If we say cat equals cat, then it is true. But this actually is not proper Java. You will run into really annoying, hard to debug errors by comparing strings like this. Because, let me show you something. There's another way of creating strings. So what we've done up until this point is creating strings using a string literal. It's called a literal because we're typing out the literal string character by character. Right? So when we're creating this string A, we're just typing out the literal string. However, there's another way of creating strings. And let me say string C equals, it's by using something called the new keyword. So in Java, new has a special meaning. You can see when I type new, it turns kind of bolded, turns a little bit purple. Just means it's a special keyword. And what do I want to create? A new string. So I create a new string, and the string, it's kind of like a method. It has parentheses, and I give it basically the string I want it to be. So here, I'm just gonna make the string cat again. So you might think, well, okay, this is kind of dumb because, well, I'm still typing out the literal string. It's just more typing. And yeah, you're generally not going to see this too often when creating strings. Usually we're just going to type out the literal. But this idea of using the new keyword will show up later. So it's good to see it for now. But just to show that this does create a string, I can print out what this thing is. Let me just print out C, and I will show you that this is indeed a string that contains cat. So yeah, here you go. So here's another way of creating strings. Put it in chat as well. The first half looks pretty much like how we normally do it. A variable type, a variable name, an equal sign. And the right-hand side is the part that's different. Here, instead of just typing out the literal string, we're using the new keyword. And then what do we want? We want a string. And what is that string? It's cat. So now let me show you something that's a little bit weird. So first, let me show you, no magic. I print out A, I print out C, or string A and string C. And you can see that they're both cat. Nothing special. They're just the string CAT. The problem now is that if we try to do A equals C, let me hit run, and now we have a problem, right? Because we use this equal sign, the double equal sign equality operator, and all of a sudden now it's saying they're not equal, right? It's saying false right here, even though we can literally see that A is cat, C is cat. So they should be the same string, right? They both say cat. But if we use the double equal sign, it gives us false, which is probably not what we want. So the question is, okay, how do we fix this, right? How do we actually compare strings? And luckily, there's several ways you can do it. The proper way to check equality is by using a method. So the equals method in this case. So instead of a double equal sign C to check equality, we want to do a dot equals, and then you put C inside the parentheses as input. And what this does is it checks if your input is the same as this thing. So it checks if string C is the same as string A. And this does what we want string equality to do. It says true, right? So just to recap, if we do what we did for numbers, we get strange behavior. If we use double equal sign, it goes as false. So I should reprint line like that. If we do the double equal sign, it goes as false. If we do the correct method, dot equals, it gives us true. And I can also show you everything else, all the other qualities will work. So if I say a dot equals b, does cat equal dog? Well, no, obviously it doesn't. So it gives us false. And I can do, say, cat here. Does cat equal cat? Yes, it does. So this is what we actually want, the dot equals method. And I'll go roughly quickly into why it is the case that this double equal sign kind of gives us the wrong thing when this method gives us the right thing. But besides that, are there any other questions so far about what I covered? The new way of creating the string, and this is the proper way of comparing strings together. And also the adding strings together. So let me go to the slides. This stuff just has the examples that we did. And so I want to talk quickly about the difference between the double equal sign and the dot equals. And so they're both checking equality in a sense, but they do it differently. And what is that difference? Well, in computer science, when we're running our code, we have something called addresses or memory locations. And basically, in our computer, all of our code is being stored somewhere, right? When we run it, somewhere on our computer, there's zeros and ones that represent a variable. And there's a location where that's being stored. And that location is called the address, or the address tells us where that location is. And so what the double equal sign does is actually just check addresses. Do these two things on either side have the same address? On the other hand, the equals method doesn't check addresses. Instead, it checks whether the contents of the two things are equal to each other. So it doesn't care if two strings have different addresses. It checks what the value of that string is and whether or not the value is the same. And so, as you might imagine, this is usually what we want when we're comparing strings. We don't care if they're stored in the same location. We care if character by character, are they equal to each other? Is the value of the string the same? Right. And really quickly, why two strings might have different addresses or two strings might have the same address. There's something in Java called the JVM. And the JVM is basically this kind of, stands for Java Virtual Machine. You can think of it as kind of an imaginary computer that runs your code. And this computer has a couple different rules. The first is well, when you create a string, this virtual computer has to create some sort of place in memory to store the string and gives it an address. So whenever we create a string, no matter whether we do it our original way with the string literal, or if we use the new keyword, it will, this variable will have some location in memory, right? And so this variable cat is being stored somewhere in memory. And after this line, it has an address. This string A has some address. The thing at that address is the value of our string, which is CAT. Then we have another rule. If we're using the new keyword, if we use the new keyword, that means we create a new string with a new address. It has to be a new address, has to be a different location. If, however, we create another string using the same method as before with the string literal, like this. So if we create two strings using this method, the Java virtual machine actually has a shortcut. It can say, hey, we created a string earlier called cat. I see you want to create another string that stores the exact same thing. Well, I'm lazy. So instead of actually creating a new string, I'm just going to use the one I already did and just say, oh, look where I've already made my string earlier, because that's where it is. I already have it. I'm not going to make a new string for you, right? And so in this case, both A and D actually are referring to the same place in memory, the same exact string. And so in this case, not only are the values the same, CAT, but the addresses are also going to be the same. When we use the new keyword, we can't take this shortcut. When we say the new keyword, we say we want a new string. It has to be a new string. We can't reuse something we already had. I need something new. And so in this case, there's going to be a new address. And that's why when we use the double equal sign, if we compare A and C, this will give us false because they have different addresses. However, if we use the equals method, well, the equals method doesn't care about addresses. It just cares about what's at the two different addresses. Are they the same thing? And the answer to that is yes, they both contain CAT. They just happen to be in different locations. Right. So that's the slides here. Kind of a diagram of that is, well, we can have this shared string. In this case, the string is Java, not cat. But we can have multiple strings pointing to the same thing in memory. However, if we ever use the new keyword, we have to create a new thing in memory, a new string called Java, or a new string called cat, or whatever. We have to create a new string. And so in that case, our variables are going to be pointing to different places in memory, and they're no longer going to be equal if we use the double equal sign operator. All of this is just to say, when you're comparing strings, always use dot equals instead of the double equals sign. You should pretty much never use this way of comparing strings. Never. Always use this. Any questions of what I covered? Lucas, I see you have your hand raised.
So for line 14 and 15, would be a special scenario where we'd use the equals method instead of just the double equal sign.
All right, so I want to flip that question around actually. You should basically always use dot equals. You should never use this, right? You should never use the double equal sign. You should always use dot equals when comparing strings. And the reason why we should always use dot equals is because when we're comparing strings, what we care about is, are they representing the same thing? Are these two strings, do they have the same characters in the same order, right? That's what we care about. We don't care about where they're being stored in memory, the addresses. And so that's why we should never use this. Sometimes it may look like this is doing what we want. And that's because of the shortcut that when we create two strings with the same value, the Java virtual machine will just say, take a shortcut, hey, I'm just going to point them to the same address. And so it looks like this is working, but you'll get some bugs. Bugs might pop up. They're really annoying. So to avoid that, never use the equal sign, double equal sign. So that's the thing I want to say. Always use dot equals. The only exception is if for some reason you have a program where you actually need to know where things are being stored and care about the location of the string in memory, then you would use the double equal sign. But in anything we're doing in this class, in anything that you're probably gonna be doing in Java, that's not what you're interested in. So I would just say like 99.999% of the time, you want dot equals. Any other questions about dot equals or equals? I'm going to go back to this slide. So there's actually on this slide 4 different ways of working with strings. And so we talked about equals. You can probably guess what equals ignores case does. Equals is very strict. They have to be the exact same string. Equals ignores case does what you'd expect. It ignores case. So what I mean by that is if I say a dot equals cat with a capital C, this is going to say false. Right? I'm going to comment this out. And that's because, well, lowercase cat is not the same as capital CAT, right? But if I do equals ignores case, oops, I have a typo. I think it's ignore case, not ignores case. Now it's going to be true. And that's because if we ignore case, then the two strings are equal. The other way that we can do to compare strings is the compare to method. And so if I just really quickly do a dot compare to and compare it to my string b, dog, we'll see something weird. We'll see -1, right? And we can try comparing to other things. Like let's compare to, I don't know, lizard. On this, we get -9, right? So notice compare to returns a number. Equals and equals ignores case returns a Boolean, right? So this is true or false. Are they equal? Yes or no? Compare to does not give a Boolean true false. It gives a number. And what this number tells us is how these strings relate to each other alphabetically, basically. So if we get a negative number, that means this first string comes alphabetically before the second one. And that makes sense, right? A is cat. Cat starts with a C. C comes before L, right? If you look up in a dictionary, cat is going to show up first. And so that's why we get a negative number. If on the other hand, we change this to like apple, oops, then cat comes after apple. And so instead of a negative number, we get a positive number too. And if they happen to be the same, then we get 0. right? Because it's neither negative, neither positive, zero. Kind of why, but yeah. So if they're equal, compare to will give a zero. Otherwise, it'll give a negative number if the first string happens to come before. It'll give us a positive number if the first string happens to come after, alphabetically. One thing for you guys to play around with is maybe see if you can figure out what the different numbers are, right? One hint is I'll just do a couple of comparisons. So if I compare cat with dog, we get -1. If I compare to eagle, we get -2. And if we compare it to fire, we get -3. So hopefully that gives you a good clue of what the number is, but maybe next class I'll talk a little bit more about that. But the important thing to know is it gives compared to gives a number, equals gives a Boolean. Right. So I have 10 minutes left. Any questions about compare to and equals? I think the main thing to take away is just always use these methods to work with strings. Never use the comparison operators that we talked about before. You can use the plus, the addition operator, that's fine. But don't use comparison operators with strings. Instead, use these methods that are available. So in this case, I will go over 2 more methods, and that will be the end of class for today. This is probably one of the most useful methods for strings. So pay attention. This method is called the substring method. And at first it might not look that interesting, but what it does is it takes a string and cuts out part of it. So that's why it's called a substring. It starts with a big string and creates a smaller string out of it. Technically, it could be the same string. You can cut out nothing, but generally you're gonna cut out a smaller section of your original big string. And the way we do that typically is with this syntax. We have substring, and we give it a beginning index and an end index. And so, for example, we can do like create the string x, hello all, we are now in the hall, and we can do a substring like this, x dot substring beginning at 6, ending at 10. And so let me do this in my code. I'm going to create my own string. I'm going to say hello to the class. That's my string. And so if I do x dot substring, and maybe I want my beginning index to be 5. These are just completely random, and I'll do 5 and 10. If I hit run, it becomes LO, I think with a space. Let me actually change this to, I don't know, 18. Hopefully that's a little bit more interesting. Yeah. So it's LO to the C, right? So it took this big string and cut out this part of it. And the reason why it's this part of it is it's 5 to 18. And we're going to take a closer to look at that. And can ask you put it in the chat. So I put this into the chat, creating my string and printing out the substring. So let's look at these starting and ending indices. I'm actually going to change these to smaller numbers so it's easier. So maybe 2 and 5 actually. So 2 to 6. So now it's y space HE is the substring from 2 to 6. And so if we investigate a little bit, we'll notice, well, let's look at the character at index 2. Or maybe can someone tell me, what is the character at index 2 of my string? So we can just count. Maybe Deo? Can you tell me what is the character at index 2 of our string?
I'm not sure.
So indexing, we start at 0 and we're just counting the letters. So if we just count 0, 1, 2, we get to the y. So the y is that character at index 2. But maybe can you tell me then, what is the character at index 6 in my string? So you can do the same thing, just count. What is the character at index 6?
L.
Yes. Just to clarify, the first L or the second L?
The second.
I believe it's actually the first one. And so maybe you forgot the space counts. You have to count the space. So S is 0, A is 1, Y is 2, the space is 3, H is 4, E is 5, and the first L is 6.
Oh.
So yeah, that's indexing, just counting, starting at 0. Starting at 0 is the important thing. So we know that the character at index 2 is Y, and the character at index 6 is the L. And notice, if we look at what the actual substring is, one of those shows up in our substring, and one of those does not. We'll notice that the character at index 2, the Y, shows up in our substring. However, the character at index 6, which we just figured out to be the first L, does not show up at all. Right? It stops just before it. And that is the important thing to remember about substring. When we take the substring, we give 2 indices. The first index tells us where to start. The second index tells us where to stop. But what you have to remember is that the first index is inclusive. It includes the character at whatever index you put here. However, it does not include the character at whatever index you put here. So it includes this one, does not include that one. And so this is important when you're trying to take a substring of here. So for example, if I wanted to cut out hello, well, I say it starts at index 0, 1, 2, 3, 4. So I want to start at index 4. And where does this end? Well, that's 4, 5, 6, 7, 8. The O is at index 8, but I have to put 9 here because I want everything up until 9, which is the space. I want to include the 8. And so that means I have to put 1 more here. And so if I run this, this is going to give me hello, which is what I want. One last method before we end class and go over the homework is the replace method. And so replace kind of is not too confusing, I think, in my opinion. It takes some sort of pattern that you're looking for and some pattern to replace it with. So if you've ever, like in Microsoft Word or Google Docs, done like Control F and replace, this is what it's doing. It's finding and replacing. So it will actually replace everything in the string. So we're finding LL in this case and replacing it with AA. Right. The thing is, it does not modify the original string. It instead creates a new string that we can assign to a new variable. So the original value of X does not change. X is always going to stay the same. but instead it just gives us a new string that we can use later on down the road. Lucas, I see you have your hand raised.
What if you set the beginning parameter to nothing?
The beginning thing,
Yeah.
or
What if it's just blank? Like what if there's nothing there?
all right, so we can try that out really quick. I do want to go over a couple examples of it. So if we do x dot replace, right? Replace, and you said, what if we do nothing?
Yeah, there's nothing
Let's
to
play.
things.
Well, if we run this, you'll notice it basically will put a bunch of AAs everywhere. And so what it's actually doing is, let me actually change this to maybe the pipe. We can see it puts it around every single character. And it's kind of weird because we're looking for nothing. And the way Java interprets this is we find nothing everywhere, right? So like between the S and the A, there's nothing. And so we put this thing there, right? So that's why it shows up everywhere, right? If we do something that doesn't exist, so like replace the X's or 2 X's with that, well, it just replaces nothing, right? Because it can't find it anywhere. So it doesn't replace it at all. If we do change it to like replace the E's or maybe the S's, because there's multiple S's. Let's replace the S's with Z's. Well, here, it does not replace the first one because case is sensitive. This is a lowercase s, this is a capital S. And so it leaves the capital S alone. But these 2 S's, it will replace. And the last thing I want to go over, and I'm a little bit over time, is you can put a space in the first one. And spaces, it will just find and replace spaces, as you'd expect. And last but not least, you can put nothing in the second operator. And what that does is it replaces whatever it finds with nothing, which means it just deletes it. And so if we do this, we can see that this gets rid of the spaces in my string because it finds the spaces and replaces them with nothing. So I know I'm a little bit over time, sorry about that, but that's all I had for lesson material. I'll post the homework to Google Classroom as usual. I'll post instructions and what to do. But before we go off, I want to see if anyone has any last minute questions. Happy to answer them now. If not, we are at the end of class and we'll meet again next week. Please try to do the homework though, and reach out if you have questions.
Yeah, bye.
You're welcome, Dale. You're welcome, Lucas. Bye, Kaden. Tushar, do you have any questions?
Trisha, you have any question?
No,
Okay.
thank you.
Okay. Bye, Tushar.
Thank you, Jack. I think it's good. The students are good at it, right?